Have you ever, when you look at like something that someone's just tossed aside, and you're like, wait a minute, there's got to be something useful in there, like some hidden potential,
Oh, yeah,
some value waiting to be unlocked.
absolutely.
Well, that's exactly what we're diving into today. This whole idea of turning what we usually just think of as trash into valuable resources. It's a fascinating story.
Yeah, it is. You mentioned wanting to understand more about how we can manage organic waste sustainably, right? And well, I think we found a really cool case study for you. This company called Sustainable Resources. They've got this innovative approach to recycling organic waste.
Yeah. And we got a ton of info here, excerpts and things,
Mm.
detailing the whole background of this company's leadership team, their long history in Australia and Hong Kong,
Yeah.
past ventures, and this really significant project they've got going on right now over in Guangzhou, China.
Right. So with this deep dive, we're going to really dissect how this team's work has evolved over time. We're going to look at the core principles that have kind of been driving their approach. And super important, we'll explore the potential environmental benefits of their latest project.
Okay, so let's unpack all of this. Let's rewind the clock. We're going back to Australia. Between 1999 and 2006, that's when things kicked off with a company called Sunburst Nominees Alpini Ltd,
Okay.
founded by David and Christopher Ellery down in rural South Australia.
Right.
And what's interesting is that they got government and local support right from the get-go.
Yeah. That initial backing is so crucial. It gives legitimacy to these kind of innovative environmental projects. It's like the community recognizing, hey, this could actually be good for us. And Sunburst nominees, they were all about that organic waste from households and farms. And as we know, that makes up a huge chunk of the waste we generate.
But here's where things get really interesting. They developed and ran what they called the first large-scale earthworm processing facility of its kind in the world.
Yep.
I mean, you think worm farm, you think something small, right?
Great.
But picture that on an industrial scale. That's a whole new way to think about waste management. So what were they actually doing with all those worms? On such a huge scale, I mean.
So they were harnessing the power of vermiculture. They were using tons of earthworms, like literally tons of earthworms, to efficiently break down organic waste. And what they ended up with, top-notch organic fertilizers.
Mhm.
And they supplied these to customers in the region.
Okay, so that makes sense. The natural system is circular, right?
Exactly.
It comes full circle. But then they took a leap from the Australian countryside to the hustle and bustle of Hong Kong. Between 2006 and 2009, Sunburst nominees kind of morphed into Sunburst Biotechnologies Ltd.
Okay.
And according to what we found, this expansion was driven by all the media attention they were getting, both in Australia and across Asia. So word was spreading about their worm-powered waste solution.
Yeah. Yeah, it really was. So the move to Hong Kong, it involved bringing in local experts to work alongside David and Christopher Ellery. And they shifted their focus to target these big waste producers. We're talking about the Hong Kong Jockey Club.
Yeah.
They handled all the stable waste for the 2008 Beijing Olympics equestrian events, McDonald's Hong Kong, every single restaurant, and a bunch of massive hotels all dealing with tons of food waste.
That's a huge step up in scale and complexity compared to what they were doing back on those Aussie farms. And all these big players, they actually adopted Sunburst Biotechnologies methods.
They did. And they even set up a whole new facility in the new territories. Sounds like they were making some serious progress on tackling Hong Kong's waste problem.
Yeah, they were gaining some serious traction. It shows you that those core principles they developed, they could actually work in a totally different urban environment.
Yeah, exactly. It's super fascinating to see how they took what they learned in Australia and applied it to these massive commercial waste streams.
But then there was a hitch. In 2009, the facility shut down. The global financial crisis hit. And from what we can tell from the sources, there was a misunderstanding with the Hong Kong government about their processes. So it just goes to show you, right? Even when you have a groundbreaking solution for the environment, you got to be proactive. You got to communicate clearly with regulators to avoid these misunderstandings and make sure you can keep things running in the long term.
Yeah, for sure. It highlights the real-world hurdles these pioneers can run into, especially when they're introducing new tech and trying to navigate existing regulations. Sometimes education and just plain clear communication are just as crucial as the innovation itself.
Now, running kind of parallel to all of this, starting around 2000, there's this other piece of the puzzle that comes into play. The Soil Food Web Institute Australia, SFI, for short.
Okay.
It was first set up by Dr. Elaine Ingham. She came over from the U.S. The institute focused on all the complex science behind healthy soil.
Mm-hmm.
And in 2009, David and Christopher Ellery, they took over SFI's operations. So the team was branching out strategically, expanding their expertise.
Yeah, this acquisition, it's a big deal. SFI, they brought in this deep scientific understanding of how soil biology works, how to boost those crop yields using organic inputs, both solid and liquid. Their work focused on identifying and solving soil problems by getting those natural microbes in the soil to thrive.
So they were bringing a science-backed approach to improving soil fertility. They even ran workshops teaching farmers all about this microscopic world beneath their feet
Right.
and how to use it to their advantage. And the potential benefits are pretty huge.
Right. Oh, for sure. I mean, less reliance on synthetic fertilizers, maybe even eliminating them altogether, and the potential for healthier, more nutritious food. I know that's something people care a lot about these days.
Yeah, absolutely. It's about creating a healthier agricultural system from the ground up, literally.
Exactly. And, if we zoom out a bit, the core principle of SFI, using the right organic inputs and managing the soil biology effectively, it totally complements their work in waste recycling. It gives them a really high value and scientifically sound way to use those recycled materials. The SFI acquisition, it wasn't just about expanding, it was about vertical integration. It gave them a guaranteed outlet for those recycled materials and established them as the experts in soil health, a really smart way to create a truly circular business model.
Okay, so fast forward to 2011. We see the birth of Sustainable Resources Ltd. This venture brings Sei-Chi Kai, who was a senior manager at Sunburst Biotechnologies back in Hong Kong, together with David Ellery. So it's a reunion, a continuation of the work they've been doing together. The sources even point out that this core team has been at it for over 25 years.
Wow.
That's a lot of combined experience in transforming organic waste.
Yeah, it's huge. That kind of longevity and the fact that these key people are still working together, it speaks volumes. They've got this deep institutional knowledge. They really get the challenges and the opportunities in this sector. It's all built on decades of hands-on experience, learning from their successes and their setbacks.
And their main goal with Sustainable Resources: keep pushing forward with the principles and practices they've developed in all those earlier organizations. Their big project now is setting up a massive organic waste recycling facility in the Kongwa district of Guangzhou in southern China. And they're even working with the Hong Kong Jockey Club again, this time in mainland China, to manage their stable waste. So in a way, they're picking up where they left off in Hong Kong, but on a much grander scale.
Yeah, exactly. And the scope of this new facility is way bigger. They're planning to handle a whole variety of organic waste streams from the region. It's not just the HKJC stable waste and their own food and green waste. They're looking at animal manure and sludge from farms, maybe even human biosolids if they can get access to those and if it's permitted. They want to process food waste from restaurants and food processing plants, and even green waste that the local government collects from parks and public spaces. It's a really comprehensive approach to managing the region's organic waste.
Okay, so they've got all this diverse waste coming into this facility, but what exactly are they going to turn it into? What are the actual valuable outputs they're planning to produce in Guangzhou?
Well, they've got a pretty diverse and strategic plan to get the most value out of that incoming waste. First up, they want to capture methane gas, and that methane, they can use it to power the whole facility itself. Any extra electricity they generate could even go back into the local power grid. Plus, they can use that biogas for heating the facility, which is a big plus during those colder months.
So they're basically using the waste to power their operation. That's smart. It's the whole circular system in action. But beyond energy, what other useful stuff are they aiming to create?
Oh, they're also going to be producing liquid fertilizer. It's a direct way to utilize the nutrient-rich liquid byproduct that comes out of some of their core processes. And remember their roots. Well, they're going back to those. They're going to be using large-scale vermiculture, those earthworms again, to process the solid organic material. They'll create high-grade organic fertilizers that can be used in agriculture across the whole region. It's a really cool full-circle moment, connecting those early innovations to this massive new project.
And that ties right back into the expertise they got from the Soil Food Web Institute. They're even planning to offer advice and support to local farmers, helping them make the most of these organic fertilizers and understand how to manage their soil for optimal health. So it's not just about the recycling plant itself. It's about building a whole sustainable ecosystem in the area.
Absolutely. And this integrated approach, that's what makes them stand out. They're not just focused on getting rid of waste, they want to squeeze every bit of value out of it at every single stage, creating this cascade of useful products and services.
Okay, so let's get into the nitty-gritty. How do they actually make all this happen? What's the overall technology they're using in this new facility?
So their big strategy is all about combining a bunch of well-established technologies, but in a new way, in a way they think is really synergistic. And the main theme here is adding value at every single step. The main stages they use are anaerobic digestion for the carefully blended organic waste streams, a controlled pre-composting phase for the solid leftovers from that digestion, and then large-scale vermiculture.
So anaerobic digestion, composting, and worm farming, but supersized, right? It sounds like a really orchestrated system. And what's the ultimate aim of this whole multi-stage process?
The goal is to achieve highly efficient organic waste recycling, and they want to do it with minimal odor. That's really important because, well, let's face it, waste processing facilities sometimes don't have the best reputation when it comes to smell.
You're telling me, yeah, if you want the community to be on board, you got to keep those odors under control. Okay, so let's break it down. Can you walk us through the process step by step?
Sure. So it all starts with receiving and mixing all the different types of waste that come in. Each waste stream is delivered and stored separately, then carefully weighed. And here's the crucial part. They've got an on-site lab that tests the carbon to nitrogen ratio of every single waste type.
Oh, wow. So they're customizing the mix for decomposition, tailoring it based on what kinds of waste they've got on hand.
That's exactly it. They come up with the perfect recipe to make sure the anaerobic digestion works as efficiently as possible.
That's pretty cool. So once they've got this ideal mix, what happens next?
So the blended waste goes through this system called hydropulping. It's basically like a giant industrial strength blender. It uses sharp blades and water to create a smooth slurry. That way, the feedstock is perfectly mixed and ready for the anaerobic digester.
So it's like a giant high-tech waste smoothie. Where does this liquid mixture go next?
Then, the slurry is pumped into these huge sealed tanks. This is where the anaerobic digestion magic happens. Inside the tanks, there's no oxygen. It's the perfect environment for anaerobic bacteria, these microorganisms that actually thrive without oxygen. They're the ones doing the heavy lifting, breaking down the organic matter. And this breakdown happens in 4 distinct stages: hydrolysis, acidogenesis, acetogenesis, and methanogenesis. Think of it like a multi-course meal for these microbes. First, they break down the complex molecules and they turn them into simpler acids, then it's on to acetic acid, and finally, the main amine producing methane gas.
And it's during this anaerobic digestion process that they get those valuable outputs, right?
Exactly. The main products are biogas, which is mostly methane natural gas, basically, and then you have 2 types of digestate, one liquid and one more solid. Once the anaerobic digestion is done, they use special screw presses to separate the solid digestate from the liquid, squeezing out any excess water.
So they've got their biogas and 2 kinds of digestate. What happens to all this stuff?
Well, most of the liquid digestate is recycled right back into the anaerobic digestion process itself. But any excess they have can be sold as liquid fertilizer or used to adjust the moisture levels of the solid material before it moves on to the next stage. And that next stage is a short period of aerobic composting for the solid digestate.
Okay, so aerobic composting. That means they need oxygen for this stage, right? They're going from a no oxygen environment to one where oxygen is essential for the solid byproduct. And after that, it's time for the worms to take over.
Exactly. The vermiculture stage is where they introduce specific types of earthworms into the pre-composted material. And as these worms munch their way through it, they produce castings that are packed with nutrients that plants can easily absorb. This final product, it's called vermicast or vermicompost.
And we talked about how this vermiculture process is considered cold, meaning it doesn't get super hot or smelly. That's a big plus. And didn't we say something about the worms actually helping with odor control?
Yeah, the earthworms actually eat the bacteria that cause those stinky smells.
No way.
They basically gobble up the stink. Plus, vermicomposting can wipe out harmful pathogens, and the final product is pH neutral, which is perfect for healthy plant growth.
So once the earthworms have done their thing, they harvest this super nutritious vermicast, they screen it to get rid of any big chunks that didn't get broken down, and then it's ready to be used as high-quality organic fertilizer. It's a remarkably efficient and well-thought-out process.
It really is. And throughout the whole system, they're super focused on quality control. They're running lab tests at different stages to make sure everything's running smoothly. And those final products consistently meet their high standards. For instance, they test the vermicast for microbial activity to make sure it's going to give those farmers tangible, quick results when they use it on their fields.
And they don't just hand over the fertilizer and say good luck. They go the extra mile, offering advice and support to those farmers, helping them figure out the best way to use those organic products and understand how they can benefit soil health and crop yields. It's a holistic approach, not just a sales pitch.
You got it. They're all about empowering the local farming community, sharing knowledge so those recycled products can be adopted successfully for the long haul.
Now, let's zoom out a bit and think about the big picture. We touched on this earlier, but how does this kind of facility contribute to environmental sustainability?
So, to get straight to your point about sustainability, one of the biggest wins here is how much organic waste they're keeping out of landfills. This means those landfill sites can operate for longer. Plus, it drastically reduces the amount of methane gas that gets released into the atmosphere when that organic matter breaks down. And less methane means the potential to earn carbon credits, which adds another incentive to adopt these sustainable practices.
And landfills, those are like methane factories, right? Methane is a much more potent greenhouse gas than carbon dioxide, so diverting all that organic waste is a huge win for the environment. You also mentioned that anaerobic digestion itself has a bunch of environmental advantages.
Oh yeah, a whole bunch. As we've talked about, it's a big part of reducing waste and keeping it out of landfills. But it also lets them generate renewable energy from that biogas they capture. They can turn it into electricity, use it for heating, or even upgrade it to biomethane for transportation fuel, which means we rely less on fossil fuels.
So it's a win-win. Less polluting waste and cleaner energy alternatives. What other environmental pluses does anaerobic digestion offer?
Well, it's a big player in cutting greenhouse gas emissions. They're capturing and using that methane that would otherwise escape into the atmosphere. And the digestate they get, it's packed with nutrients, making it a great natural fertilizer. So there's less need for those synthetic fertilizers, which have their own environmental downsides. Plus, anaerobic digestion is better at controlling odors compared to regular composting, and it can even help conserve water. It reduces the water content of the waste, and when they apply the digestate to the soil, it helps the soil hold on to water better.
It sounds like a versatile and environmentally sound technology for dealing with organic waste. And I remember from our research that it can handle a wide range of waste types, which is essential for a truly comprehensive solution.
Absolutely. This flexibility really helps promote a circular economy where waste is seen as a valuable resource, something that can be transformed into energy and stuff that improves the soil. So in the end, by taking pressure off landfills, reducing harmful emissions, and keeping pollution in check, anaerobic digestion does a lot to protect the environment as a whole. It helps safeguard ecosystems and conserve our natural resources. It's a fundamental shift towards a more sustainable and responsible future for waste management and energy production.
Okay, it sounds like a really promising approach, but let's be real. Are there any potential downsides? Are there any risks of causing other types of pollution that we should be aware of with a facility like this? I think it's important to look at things from all angles.
You're absolutely right. Like any industrial process, if they're not careful, anaerobic digestion and all the related stages can lead to other kinds of pollution. We've got to consider things like air emissions from burning the biogas, the possibility of methane leaking from the system, and odor problems if they don't manage things carefully.
Right, even burning biogas produces some byproducts, and methane is such a potent greenhouse gas that even small leaks can have a big impact. What about water pollution?
Yeah, that's another area to watch out for. They have to store and manage that digestate properly to prevent nutrients from washing into nearby waterways. And there's always the risk of spills or leaks from the digesters themselves, which could contaminate both water and soil.
And what about soil contamination? That seems kind of counterintuitive given that they're producing fertilizer as a final product.
It does, but depending on what kind of waste they start with, that digestate could end up containing heavy metals or other contaminants. So they've got to be really careful. They need to keep a close eye on the input materials and the final digestate, and they've got to make sure they're applying it correctly to avoid contaminating the soil. There are also other things to think about, like noise pollution from the facility's operations, the possibility of pathogens growing back in the digestate if it's not treated properly, and how they're going to dispose of any leftovers that can't be digested.
Okay, so it's not a totally risk-free process. But it sounds like these potential issues are known and can be addressed. Didn't the sources mention strategies to mitigate these risks?
They did. This is where careful planning, solid engineering design, responsible operations, and constant monitoring come in. They can't just wing it. The sources detail a bunch of strategies, like using advanced air pollution control tech when they burn the biogas, installing systems to upgrade the biogas and detect leaks so they minimize methane emissions. And for managing that digestate, they need proper storage, the right treatment processes, and they've got to follow best practices when applying it to prevent water and soil contamination. Using things like biofilters to control odors is also essential, and they can take steps to reduce noise from the facility. And of course, they need to monitor their environmental performance really closely and report on it regularly to make sure they're complying with regulations and always looking for ways to improve.
So in the end, it comes down to responsible implementation. They've got to design it right, operate it carefully, and keep a close eye on everything to make sure they're getting the most environmental bang for their buck while minimizing any potential negative impacts.
Exactly. It's all about environmental stewardship, recognizing that to truly benefit from these sustainable technologies, you've got to be committed to doing things the right way.
Well, we've certainly had a thorough look at sustainable resources and all the amazing work they're doing. To wrap things up, what are the key takeaways you think our listeners should walk away with from this deep dive?
The big things to remember are the impressive long-term vision of this team and how their work has evolved over 2 decades in this field. Their approach to managing organic waste is really smart. They're combining anaerobic digestion, pre-composting, and vermiculture to make most of what many people see as just a waste problem. And their new, ambitious facility in Guangzhou has the potential to make a real difference for the environment. Not only are they going to drastically reduce the amount of waste going to landfills, but they're also creating renewable energy and helping to improve the health of the soil in the region.
So our listeners now have a much better understanding of how this organization is tackling the challenge of organic waste head on. They're not just getting rid of it, they're transforming it into valuable resources and contributing to a more sustainable future. It's a great real-world example of how those circular economy principles can be put into practice.
And seeing the potential of these combined technologies, it really begs the question, what other waste streams in our communities could benefit from this kind of innovative, value-added approach? And what can you, as an informed individual, do to support and encourage these kinds of initiatives? It's a chance to think bigger beyond your own personal waste habits and consider the whole picture of resource management and environmental responsibility.
That's a powerful thought to leave us with. Thanks for joining us on this deep dive into such a fascinating and important topic.